Hi, our project is called Policy-Based Data Exfiltration Detection using Provenance. Our goal is to detect the exfiltration of data in the cloud environment. So in this case, we split the cloud into zones. Some of the zones are sensitive and some of them are general. On each of the machines or in the cloud, we install a provenance logging agent which collects the provenance data from all the machines. Once these data are collected, we transmit these logs to a central location or the security management zone, where the correlation and the analysis are done. In the case of data exfiltration attack, the attacker does some actions. So we have three phases of attack before the exfiltration of data. In the first phase, the attacker copies the targeted data, renames it, and moves it to a different location on the same machine before the exfiltration. Then he extracts these data from the sensitive zone to a drop point in a general zone outside the sensitive zone where the data are located. From this drop point, the files are then exfiltrated to an external destination outside the cloud. So we have three phases. The first one is the data leakage within the same machine. The second one is the data leakage across machines or between zones. And the last one is the data exfiltration to an external destination outside the cloud. In our demo, we concentrate on the data leakage within the same machine, and we detect four actions. The first one is copy, second one is rename, third one is move, and fourth one is move and rename. In the case of copy, we detect when the attacker copies the content of the sensitive file using the command Linux cp. In the case of rename, we detect when the attacker renames the sensitive file inside the same directory using the command Linux rename. In case of move, the attacker changes the location of the sensitive file within the same machine using the command Linux move, but he doesn't change the name. So in the last one, we detect when the attacker changed the location of the file while changing its name using the command Linux mv. In our project, we used Progger, which is a open source to collect the provenance data from the machines in the cloud. Then these data are transmitted to the zone 6, so the security management zone, where we have a rule-based correlation engine, so called SEC, which is also an open source, simple event correlation. So this open source will detect when an action is done, action of copy, rename, and move. Then these events are sent to Ponder, which is a policy management system, who will decide if this is an attack or not based on the specification or the property of the file. If the file is sensitive, any action done on this file is sent as alarm to the user, otherwise nothing will be sent. Now we will show you the demo. So we have the user machine. Here we have a VM where a Progger is installed, and we have the IC4, which is inside the security management zone where SEC is installed, and the last one is this machine, which is also located within the security management zone and where Ponder is installed. So we have already Progger running on the test machine, and Ponder is running on inside the security zone. I will just run SEC on the IC4 machine. We could have SEC running, so we run it once and we leave it running all the time in the background. I just run it here to show you in the demo how to do it. So it's a Perl. And we have the rules inside this file, the rules of copy, rename, move and rename, and the input is from a pipe, so in this case called July test. So SEC read the progress data or the provenance data over this pipe. So now we run SEC, and now I will try to do some actions on the machine and see if we get the alarm or not. So we have here many folders already created, and we have some sensitive files in them that we already created and specify them as sensitive or general inside the policy. So I will start by the folder work. So as we can see here, we have two files, the IC4 patent.docs and my payslip.pdf. And if we go to the policy, we can see that these two files, the IC4 patent is confidential and my payslip also is confidential. So these are specified as confidential in the policy. Now if I try to do the copy action on the file IC4 patent inside the folder work, so I will copy it inside the same machine, and I will do the file name as IC4 patent copy. So as we can see here, an alarm pop up that this file, which is sensitive as specified in the policy, is copied as the IC4 patent copy by the user test in the directory work at the machine IC4 VM1 at the time 9:28 AM. Now if we try another action like rename, so we rename the second file, which is my payslip, and I will rename it as Linux library, so liblinux.zip, IC4 my payslip.pdf. So we see again an alarm that this file, my payslip.pdf, which is also sensitive, is renamed to liblinux.zip by the user test in the directory work on the machine IC4 VM1 at the time 9:29 AM. Now we'll try the third action, move. So I will move a file from the directory college, and this file is called examresults.xl. So I will move this file to a different location, so in the folder pictures, and I will keep the same name. So before doing the action, I will just double check in the policy that this file is confidential. So we have here exam results is confidential as well. So if we do the action of move, we have again an alarm so that the file exam results is moved from the folder college to the folder pictures by the user test on the machine VM1 at 9:30. So now we will try the action of move and rename. So I will move a file from the folder personal file personal, and this file is called my medical data, sorry, my medical report dot text. I'll move this file to the front location, and I will change the name. So I did move the file from the personal directory to the games, and I will call the file as executable and call it zombie cow. So as we can see, again we have an alarm sent to the user, so saying that this file, my medical report.txt, is moved from the personal directory to the games directory and is renamed as executable called zombie cow by the user test on the machine VM1 at the time 9:31. So now we'll try to do the action of copy on a general file, just to make sure that we will not have alarm for this file because the user didn't specify it as sensitive. So this file is called IC4 newsletter, which is not sensitive, and I will copy it inside the same folder with the name IC4 newsletter copy. So before doing the action, I will show the policy again, and as we can see here, the IC4 newsletter.txt is specified as general. If the file is not specified as confidential in the policy, it means that it's general by default, but we can specify it more or double write it, double specify it as we did here in the policy, and put it as general. So now if we do the action, we see that this action is detected by Ponder, but we don't have an alarm because this file wasn't sensitive, so it was general. So we'll do another action, for example the action of move. So we'll move the same file from the same folder .text, IC4 newsletter.txt. I will move it to a different directory, so I will move it to the trash, and I will keep the same name. And as we can see here, the action is detected again by Ponder, but we don't have an alarm sent to the user to report this action because the file was general and not sensitive. So in this demo, we showed you our system to detect the data leakage within the same machine, and we detect the actions of copy, rename, move and rename, that it can be done by an authorized user or an attacker on a file within the same machine. And in the next work, or for the future work, we will do the data leakage within the cloud between zones. So if somebody move the file from the sensitive zone to a different zone, this should be detected. And we will finally do the data exfiltration to a destination outside the cloud. Hope that you did enjoy our demo, and thank you.